Hi everyone. Today we're going to study measures of variation. And these measures are range, variance, and standard deviation. Let us define measures of variation. This is sometimes called measures of dispersion. Measures of variation are values that describe how far the data are from one another. Let us study the first measure. This is the range. Range is denoted by R. In a raw data, range is the difference of the highest value and the lowest value. In a frequency distribution, it is the difference of the upper limit of the last class minus the lower limit of the first class. The second measure is the variance. S square is used for sample variance, and this symbol sigma square is used for population variance. The variance is the average of the square of the distance of each value from the mean. By this definition, we can write the formula. S square equals the summation of the square of x minus x bar all over n minus 1. This formula is for sample. This symbol is the summation, that is the capital sigma. The x is a raw datum. X bar is the sample mean. And this n is the number of cases. Now for population formula, we have this sigma square equals the summation of the square of capital X minus mu all over capital N. This is capital sigma, and that is read as summation. Capital X here is a raw datum. Mu is the population mean, and the capital N is the number of cases. Now we have an alternative formula. This formula is not using the value of the mean. This is for sample raw data. So we have S square, this is the variance, equals summation of x square minus the fraction whose numerator is the square of the summation of x all over n. And this is all under the denominator n minus 1. This is the summation. The x is raw datum, and the n is the number of cases. This is now a formula for sample grouped data. S square equals the summation of f times the square of x sub m minus the fraction whose numerator is the square of the summation of f x sub m all over n. And this big expression here is under the denominator n minus 1. This is the summation symbol, the capital sigma. F is for the frequency. X sub m is midpoint. And this n is the number of cases. The third is the standard deviation. S is used for sample standard deviation. Sigma is used for population standard deviation. We define the standard deviation as the positive square root of the variance. In symbol, we write S equals the square root and the variance is the radicand here. Let us see this example. Find the range, variance, and standard deviation of the distribution below. We have here two columns. The first column is the class intervals, and we have 1, 2, 3, 4, 5, 6 classes. The second column is the frequency, denoted by F. We have 3, 6, 7, 9, 10, and 4 frequencies for the classes respectively. The total of the frequency is n equals 39. Let us solve for the range, and this is the formula. Upper limit sub L. It means upper limit of the last class minus lower limit sub F, lower limit of the first class. So we have here 45. This is the upper limit of the last class, minus 16. That is the lower limit of the first class. Getting the difference, we have R, that is the range, equals 29. This is our range. Next, let us solve for the variance. In this video, let us use this formula. If we use this formula, we need to add 4 more columns in our table here. Here are the 4 columns. Let us study each column. The first additional column here is for the midpoint, denoted by x sub m. Please remember that the formula for the midpoint equals lower limit plus upper limit all over 2. So the numbers for the column of midpoints are here: 18, 23, 28, 33, 38, and 43. Let's go now to the next column, F times x sub m. It means to say, let us multiply the frequency and the class midpoint of each class respectively. So 3 times 18, and we will write the answer here. The answer is 54, followed by 138, then 196, then 297, 380, and the last is 172. After that, let us take the total of this column, and that is 1237. This is the summation of this column f x sub m. The next column is the square of x sub m. It means we need to square the midpoint respectively. So it means for the first blank, we need to write here the 18 square. So the numbers will be 324, 529, 784, 1089, 1444, and 1849. Going to the last column, this is f times the square of x sub m. It means we need to multiply the frequency and the numbers of this column respectively. So 3 times 324, we will write the answer here. So the numbers are 972, 3174, 5488, 9801, 14,440, and 7,396. After that, let us take the total of this column and write here. We have 41,271. This is the summation of f times the square of x sub m. Now we are ready to solve the variance. These two numbers in blue are the ones that we need in our formula. Substituting now the values, we have s squared equals 41,271 minus the square of 1,237 all over n, that is 39, and all over n minus 1, which is 39 minus 1. Simplifying further, we have now this fraction here is simplified into 39,235.1. 39 minus 1 is 38. So what we'll do next is to get the difference of the numerator and divide the answer with 38. So the value of s squared equals 53.57625. This is the variance. Next is the standard deviation. We say that s equals the square root of the variance. Getting this answer here, we have now the square root of 53.57625. So the value of the standard deviation is 7.31958. This is our answer. Let us see this example. Find the range, variance, and standard deviation of the raw data 2, 3, 6, 7, and 9. For our solution, let us write this data in a column, and the heading is X. Now, let's start by solving the range. That is the highest value minus lowest value. We can see here that the highest value is 9 minus the lowest value is 2. 9 minus 2 is 7. This is now the range. Let us now compute for the variance. The formula is given here. The first step now is to get the summation of this column x. So we have summation of x, or the total of this column, equals 27. Let us now solve for the mean. This is the formula. X bar equals summation of x over n. Summation of x is 27 over the n here is 5. There are 5 numbers in our column. 27 over 5 is 5.4. Next, let us write another column describing x minus x bar. This is each datum minus the mean. So in the first blank here, that is 2 minus 5.4. So we have negative 3.4. And the next will be 3 minus 5.4 is negative 2.4. 6 minus 5.4 is positive 0.6. 7 minus 5.4 is 1.6. 9 minus 5.4 is 3.6. After this, we need another column to square each data in this column. So negative 3.4, if we square this, we have positive 11.56. The square of negative 2.4 is 5.76. Square of 0.6 is 0.36. 1.6 square is 2.56. 3.6 square is 12.96. Then we need to get the summation of this column. So we write summation of the square of x minus x bar. The total is 33.2. This value here is what we need in our numerator in this formula. So we have 33.2 all over, and minus 1 is 5 minus 1. This 5 minus 1 is simply 4, and the quotient 33.2 over 4 is 8.3. This is now the variance. Next is the standard deviation. We say that S is simply the square root of the variance. So we write S equals square root of 8.3. And the answer here is 2.9. This is the standard deviation. Today we're going to study coefficient of variation. Let us define coefficient of variation denoted by CV. Coefficient of variation is a measure to compare the standard deviation of two sets of data if the units are different. The formula is here. CV, that is the coefficient of variation, equals the fraction whose numerator is standard deviation over the mean times 100%. In comparing respective coefficient of variation of two data, the data set with less coefficient of variation has less variation and said to be more consistent. Let us see this example 1. The average score of students in a calculus class is 110 with standard deviation of 5. The average score of the students in a statistics class is 106 with a standard deviation of 4. Which score is having more variation? For our solution, let us write the formula for the coefficient of variation. Then let us compute for the coefficient of the calculus class, which is equal to 5, that is the standard deviation, over 110, which is the mean, times 100%. Using our calculator, the value is 4.54%. Next, Let us compute for the coefficient of variation of the statistics class. And that is 4, that is the standard deviation, over 106, that is the mean, times 100%. This is equal to 3.77%. We say that calculus class has more variation because its coefficient of variation is more. This is our final answer. Let us see this example 2. Find the coefficient of variation of the ages of 5 children. And the data are 3, 6, 10, 12, and 8. For our solution, let us rewrite this data into a column, into a table. And this column is represented by x. Let us now compute for the mean. The formula is x bar, that is the mean, equals the summation of x over n. Solving for the mean, let us first compute for the total of this data. That total is the summation of x, which is equal to 39. So this value of summation of x, we will now substitute to the numerator. So we have 39 over n, and that n equals 5, because there are 5 data here. The quotient is now 7.8. This is the mean. Next, let us compute for the standard deviation. We have this formula S equals the square root of the quantity. This is a fraction, and the numerator is the summation of the square of the quantity x minus x bar all over n minus 1. In using this formula, we need to add 2 more columns. The first column here is the difference of each data from the mean. So we have this first blank, we will have 3 minus the 7.8. So that is negative 4.8. The second blank is 6 minus 7.8. And the difference is negative 1.8. Next, 10 minus 7.8. And we have 2.2. Next is 12 minus 7.8. And the answer is 4.2. The last blank is 8 minus 7.8 equals 0.2. The next is for us to fill up the last column. In here, we're going to square each data respectively. For the first blank here, this is now the square of negative 4.8. So that is now positive 23.04. Next, the square of negative 1.8. So we have positive 3.24. The square of 2.2, and it is equal to 4.84. The square of 4.2 is 17.64. The square of 0.2 is 0.04. The next is, we will get the total, and that will be the summation of this column. That is the summation of the square of the quantity x minus x bar. And the value is 48.8. This value is what we need in our formula here. Substituting the values, we have now the square root of 48.8 over the n minus 1 is 5 minus 1. The 5 minus 1 is 4, and we get the quotient of this fraction. We have now 12.2. So the square root of 12.2 is the standard deviation, which is equal to 3.49. Next, the coefficient of variation with this formula, standard deviation over mean times 100%. Substituting the values, we have 3.49 over 7.8 times 100%. Simplifying this equation, we have now 44.7%. This is the coefficient of variation. This is our final answer. Today we're going to study Chebyshev's theorem. What is Chebyshev's theorem? Chebyshev's theorem estimates the minimum proportion of observations that fall within a specified number of standard deviations from the mean. If you have a mean and standard deviation, you might need to know the proportion of values that lie within, say, plus and minus 2 standard deviations of the mean. Chebyshev's theorem helps you determine where most of your data fall within a distribution of values. There are two forms of the equation. One equation determines how close to the mean the data lie, and the other equation calculates how far away from the mean they fall. The first formula is 1 over k squared. This is the formula for the maximum proportion of observations that are more than k standard deviations from the mean. The other formula, 1 minus 1 over k squared. This is the minimum proportion of observations that are within k standard deviations of the mean, where k equals the number of standard deviations in which you are interested. Take note here that k must be greater than 1. Using the formula given a while ago, we're going to construct a Chebyshev's theorem table. Here we have 3 columns. The first column for the standard deviations. We assign values here, square root of 2, 1.5, 2, 3, 4. The second column, we're going to use this formula to represent the minimum percent of observations within. The third column is for this formula, 1 over k squared. This represents the maximum percentage of data outside the standard deviations. So, when standard deviation is square root of 2, the maximum percent outside is 0.5, while the minimum percent within is also 0.5. When standard deviation is 1.5, the maximum percent outside is 0.44, while the minimum percent within is 0.56. When standard deviation is 2, the maximum percent outside is 0.25, while the minimum percent within is 75%, or the 0.75. When standard deviation is 3, the maximum percent outside is 0.11. For the minimum percent within, that is 0.89 or 89%. When standard deviation is 4, the maximum percent outside is 0.06, while the minimum percent within is 0.94. For example, if you are interested in a range of 3 standard deviations around the mean, Chebyshev's theorem states that at least 89% of the observations fall inside that range, and no more than 11% fall outside that range. Let us see this example. A data set has a mean of 100 and standard deviation of 5. Letter A. What is the range of values within 2 standard deviations? Letter B. How many percent of the data falls within 2 standard deviations? Let's start with problem A. We're going to write this formula, mean plus or minus k times standard deviation. The k here is the number of standard deviations that we are interested in. Substituting the values to answer letter A, we have now the mean as 100 plus or minus the k is 2 as given in problem A, and our standard deviation is 5. So 2 times 5 is 10. So this is now equal to 100 plus or minus 10. So let us split the plus and minus. Using the plus, we will get the upper limit. So that is 100 plus 10 equals 110. For the minus, we will get now the lower limit. 100 minus 10 equals 90. So the range of values is 90 up to 110. This is the answer for letter A. Let us now solve for letter B. How many percent of the data falls within 2 standard deviations? We can go back to our table a while ago. The standard deviation of 2 is here, so our answer is the 0.75 or 75%. So we say here, Chebyshev's theorem tells that at least 75% of the values fall between 90 to 110. This is now the final answer. I hope you learned something from this video. See you again next time.